Good afternoon, everyone. My name is Fuhao from Chongqing University in mainland China. Today, my paper topic is about structured innovation in construction value engineering through large language model assisted TRIZ reasoning. As a structured process, value engineering consists of sequential phases with different goals, such as it starts with gathering information to analyze the function with improvement potential, and generated ideas to improve those functions, and finally evaluate, develop, and implement the selected ideas. Among these phases, the idea generation is the most important one because it directly affects the feasibility and quality of the final outcomes. But however, despite its centrality, the creative phase faces multiple challenges in real-world applications. For example, the one challenge is heavily relies on expert cognition. The idea generation should be based on the expert experience, and it analyzes the function with improvement. Especially in the complex and time-constrained projects, it is difficult for the expert to generate the feasibility ideas. And with the development of artificial intelligence, such as the reasoning and generation provided by large language models, it can help to reduce the cognitive reliance on human behavior. So we can use LLM to help to analyze the project functions and also to analyze the problems, try to generate the ideas through the generation capability of LLM. So in this work, we try to incorporate intelligent technologies to improve the creative phase of construction value engineering workshop. And we also use TRIZ theory. TRIZ theory, it means theory of innovation problem solving. It lies on the technical the essence lies on the technical innovation is not random, but follows repeatable patterns that can be abstract, generalized, and reused across domains. It is developed through the analysis of pattern, and the overall logic is first it used to abstract the problems into the TRIZ parameters, then retrieve the relevant innovation principles from TRIZ contradiction matrix, and finally reconcatenate those principles based on the project context. So the TRIZ theory has been proved to be valuable in facilitating systematic creative phase, but it still needs a high level of abstraction with TRIZ theory. And this largely limit the practical applications of TRIZ theory in construction industry. But as we mentioned, with the development of LLM, their capability in reasoning and generation can provide valuable solutions to reduce the cognitive barriers during the TRIZ applications. And the inclusion of project context during the value engineering can further guide LLM to be more context aware. So in this paper, we propose an integrated framework that can embed project-specific innovation into LLM-driven TRIZ reasoning to support the context-aware and intelligent idea generation during the workshop. Here is the overall ideas. It consists of 4 steps. And in step 1, it aims to abstract the engineering challenge into TRIZ contradiction models with the assistance of LLM. In traditional work, the project context and the target function obtained in the beginning of value engineering workshop is translated into TRIZ contradiction model based on expert judgment. And the involvement of LLM can transfer this into an intelligent process. As depicted in the figures, the prompt regarding basic TRIZ concept and design examples will be fed to the models. And next, we will repeat and aggregation the result. Finally, we will invite the expert to review the result to include the human-in-the-loop validation so that make sure the overall outcome is reasonable. And the second step aims to transfer the identified TRIZ contradiction model into domain-specific ideas that align with the value engineering objectives. Firstly, the prompt was designed to retrieve the principle from the TRIZ matrix. And with the principle, the prompt regarding the design example was utilized to guide the LLM to generate ideas within the specific project context. And the framework can systematically integrate the TRIZ theory and human insights into the idea generation. In the same time, it utilizes the reasoning and the generation capability of LLM. Also, the project context will also be integrated into the whole logic so that it can ensure the idea generation is an intelligent, structured, and context-aware within the construction value engineering context. And in the step 3, we develop a prototype. And as depicted in the figures, the prototype consists of 4 modules. The first module is a user interface modules using Python Tinker to allow the user input information and allow the experts to review the result, to visualize the result. Now, and the second one is an LLM-assisted abstraction modules to translate the project information into TRIZ parameters. And the third one is a TRIZ knowledge base that the LLM can utilize the information from this part to enable its reasoning logic follows TRIZ theory. And finally is the last one is a context-aware idea generation models to utilize all this knowledge and information to generate the ideas within the project context. And during the implementation, the system invoked ChatGPT, and the temperature set was based on the target. For the first part, to translate the information, the temperature is 0.5. And for the context-aware idea generation, we increase the temperature to 1 to encourage more creative idea result. And we utilize a case study to demonstrate the overall functionality. And as depicted in these figures, it follows our proposed framework and to translate the project information to find the TRIZ principles and lead LLM to follow the logic to generate ideas. And finally, the result was presented to allow the user to conduct the human-in-the-loop review. And we will use the first example as a demonstration. And within the identified TRIZ contradiction, and we retrieve the TRIZ principles from the knowledge base, and utilizing those information to lead the LLM to generate the ideas. And during the evaluation part, we conduct in 2 perspectives. First is we also invite some experts to conduct the same analysis process, and the result proves the LLM-assisted TRIZ reasoning can have the same identified result with the TRIZ expert. And next is we also conduct a brainstorming sessions focus on the same case study for around 30 minutes. And the human brainstorming generates around 10 ideas in 30 minutes, but our system can generate around 20 ideas under 2 minutes. And also we compare the idea details. We can see our part can have more creative and cover a more wider brand ideas compared with the traditional human brainstorming sessions. So all this evaluation proves our proposed framework and the developed prototype is workable and also can use to support the idea generation during construction value engineering workshop. So to sum up, our work offers a technical sound and a conceptual clear demonstration of how LLM-assisted TRIZ reasoning can be integrated into construction value engineering for structured, creative, and context-aware idea generations. It offers value insights into how LLM can be configured to transform the traditional unstructured creative phase into an intelligent system, logical-driven innovation process with reliable and context-aware results. That is all for my presentation. Thank you.
Thank you.